All right, guys, this is the volume stoichiometry worksheet, problem 2A. Let's get to it. So, with all stoichiometry problems, the first step is to balance the equation. Where the hell? Here we go. All right, so here it is. C3H8 plus O2 yields CO2 and H2O. This is propane right here. So this is the combustion of propane. C3H8, propane, burned with oxygen, produces carbon dioxide and water. So we got 3 carbons on this side, 1 on this side, so we got to put a 3. We've got 8 hydrogens on this side and 2 over here, so we got to multiply it by 4, because 4 times 2 is 8. So 3 carbons. 8 hydrogens, 8 hydrogens. Last, we got to balance the oxygen. 3 times 2 is 6 oxygens. 4 times 1 is 4. That's a total of 10 oxygens on the product side, which means if we got O2s, we need 5 of them. 5 O2s. So there is the balanced equation. A propane burned with 5 oxygen molecules will give you 3 carbon dioxides and 4 waters. All right, so now let's get to this problem. We have got 30 liters of oxygen gas. How many liters of carbon dioxide gas are produced? So we're going from liters of oxygen gas into liters of carbon dioxide. So let's get to it. First step is to take our 30 liters of O2 and figure out how many moles of O2 that is. Now, to get out of liters and into moles, you divide by 22.4. Every time. If you got liters of gas at standard temperature and pressure, dividing it by 22.4 gets you the moles. And so we've got 1.34 moles of O2. All right, next step. We got to get from oxygen moles into CO2 moles. So 1.34 moles of O2. We got to get it into moles of CO2. Okay? So to do that, we got to get out of O2 into CO2, and we look at the balanced equation. We see here that every 5 oxygens consumed will produce 3 carbon dioxide. So 3 carbon dioxides produced for every 5 oxygens consumed. So 1.34 times 3 over 5, or 3/5. So I'm going to do that. 1.34 times 3/5. And I get, let's see here, I get 0.804 moles of CO2. Now, last step, it wants not moles of CO2, but liters of CO2. So I've got to take that 0.804 moles of CO2, and I got to convert it into liters of CO2. To get out of moles into liters, you multiply by 22.4. So 0.804 times 22.4, and I get 18.0. Yeah, 18 liters of carbon dioxide. All right, so there we go. So these volume to volume problems are not so bad. All right, they're not so bad. You're just dividing by 22.4 at the start to get it into moles. All right. Then you're doing the mole conversion. So divide by 22.4, mole conversion. Then you're going to multiply by 22.4. All right, there you go.